sand in India, means it is available, but it's scarce. Many people are not finding. So now we are going to, the quarry dust, which is christened as manufactured sand. Actually, it's nothing but a quarry dust. So we are using the quarry dust as a sand. It's not a bad. It's a sustainable one way, because when we crush the quarry, or when we quarry, we get this the so-called, after the crushing or crushes produce the quarry dust. It's not a bad. It can use it because there is no sand. So look at this video, then you might understand that some of the impact of sand.
Find air in the world.
It's almost become like air. The air we breathe. We don't think too much about it, but you can't live without it.
Sand is not a sustainable resource.
No other resource is used in such vast quantities as sand, maybe with the exception of water.
Value of sand is such that it's a commercial commodity that is smuggled. I mean, it's a big business smuggling sand.
It used to be that you'd have a sand and gravel deposit, and you'd simply go and dig it up out of the ground. So you'd have sand to make your roads, bridges, and buildings out of. But that type of material has all been taken away. It's gone. We've used it already.
Actually,
as you dredge up the sand, of course, the animals and plants that are on the seafloor, they will all be dredged up as well. Whatever living communities are there will just be eliminated.
Globally, between 75 and 90% of beaches are actually undergoing some sort of retreat, and that's only going to get worse.
Okay, this is about, I think it's a very serious information regarding the sand. I'm really concerned, as a researcher, as a parent, and we should think of the next generation, and it is very serious. And I hope what you see here, the sand is not only used for cement construction in industry, but huge number of applications, electronics, cosmetics, even the sand, the paper, tissue papers, and so many other things. Sand is a precious material, so it's not available nowadays. It's very sad. But on the other hand, we saw in a country like Kuala Lumpur, Malaysia, Thailand, Indonesia, Nigeria, all these tropical countries, they do produce a lot of waste. Even India, we have a lot of agri waste in buildings. So there are so many waste, kind of hazardous waste we produce, and also some other waste. So how do we utilize those waste, industrial waste? Of course, we are also responsible for greenhouse gas emissions. At the same time, depletion of natural resources or virgin materials. Therefore, it's a perennial issue. We have to deal with this. Though some of us may end up in government agencies for policy making, we need to think of how we can utilize some of these materials. For instance, in Malaysia, say even Indonesia is the number one palm oil producing country. Thailand, Colombia, Nigeria, Ecuador, Guatemala, and Papua New Guinea. All these countries are producing palm oil or palm trees. So these palm trees, what you see here, they produce not only palm oil. There's a lot of palm oil mill effluent, the sludge, and the waste like this. Palm oil fibers, palm shells, and these waste materials are burnt in the factories to produce indigenously the power. So for a power station, they need to produce the steam, therefore they need to burn the fuel waste from the bagasse or others. So then the ultimate result is they get a palm oil fuel ash. This is a waste material. It's a pozzolanic material. We go to the factories and we identify some of the factories produce this kind of waste, and we bring them to replace the sustainer with the conventional cement. So they replace, not wholly replace, but partially replace this. So this is the from one of the industries in Malaysia. So some of this I just highlight. So towards the resilient, sustainable concrete, we have utilized some of these waste material to build a resilient, sustainable structure. So I can show you. So one of the things is this: we can eliminate the cement and use these waste materials. I mean, when you say eliminate, for your small construction, I don't mean the whole world we can eliminate the cement. Cement is the very important material, but some of these waste materials available certain countries in Malaysia, not only the palm oil fuel ash, but also we have palm oil clinker powder. Fly ash is commonly available throughout the world, and slag, we call granulated blast furnace slag, coal bottom ash, and even others are available. Metakaolin, rice ash, silica fume. These are the waste material or industrial byproducts. Whereas some of these materials also available as a fine and coarse aggregates, and rice husk can be used as a silicate. We are producing sodium silicate from here in our geopolymer concrete. Say here silicate, where you see in my cursor, this silicate we developed from this rice husk ash to be used as an activator instead of water. Because in PLM we want to remove the cement, we have to use those waste materials or byproducts like fly ash, GGPS, coal bottom ash, palm oil clinker powder, palm oil fuel ash as binders. Thereby, you can utilize this activator, sodium silicate or sodium hydroxide. Sodium silicate is an expensive commodity. Therefore, we can go and use this sodium silicate as the activator. Then we can also eliminate some of the sand, conventional sand, using the other sands that we find in Malaysia. So these materials should be sustainable. At the same time, they should be resilient, because if you look into this GGPS, palm oil fuel ash, palm oil clinker powder, rice husk ash, or coal bottom ash, and fly ash, these are some of the materials that are available. Some are traditional. This is a traditional. This has become a traditional, but other things, this is not a traditional, non-traditional. There's palm oil fuel ash, palm oil clinker powder, rice husk ash. So if you look into the silica, alumina, iron content, I'm sure this one is about 76% fall under the class F material or pozzolanic. This one class C material. So these are the pozzolanic. Some of them fall under class C, class N and F, and some of them. So based on the calcium content and silica content, they can be classified and they can be utilized. However, you see, LOI is a very important criteria. LOI is called loss on ignition. So we need to ensure that loss on ignition is below a certain percentage according to the codes. So if we know that sustainable materials or resilient materials can be, in addition to the cement, we can also utilize fly ash as a cement replacement, and GGPS, and we have a palm oil fuel ash, which is a porous, and the clinker powder is in the irregular shape or angular shape, and also coal bottom ash, rice husk ash, metakaolin, and silica fume, and others may be available. Incinerated bottom ash also available. So this material like this IBA, we call incinerated bottom ash as aggregate. This is from, they burn the domestic waste and other waste, but we need to be careful because that may consist of some arsenic contents. So we should be clear when we utilize the material, we need to check for any durability issues related to that arsenic contents or others, then we can utilize. So some of these materials that we utilized are oil palm shell, palm oil clinker, this one steel slag aggregate, and granite. So these are, if you look at the steel slag aggregates, it's almost 3 times compared to this oil palm shell, and this is one more than the crushed granite which we use conventionally all over the world. We use the crushed granite as a coarse aggregate. However, if you look into this aggregate impact value, the conventional crushed granite is almost 20 to 30%, whereas for the oil palm shell, which this one, or oil palm shell, only 7%, sometimes 4%. So that shows something unique. Therefore, we have, developed a concrete that later I can show as it can be used even earthquake prone region like Indonesia, some of the disaster zones, some of the lightweight concretes can be developed using these materials. So this one I have already explained. So what is the next one is on the resilient modern materials for resilient structures. So what we did was we want to develop or construct a house for STEM students or others international students, a small house using our resilient materials or modern materials for resilient concrete. So I will show you. One of my students has embarked on this, utilizing this rice as cash, palm oil fuel ash, and palm oil clinker powder. These are coming from our industries, rice husk industry, palm oil industry. These two from the palm oil industry, depending on the boiler, be palm oil fuel ash or palm oil clinker are available. So we brought these materials to the laboratories, and my student also utilized recycled concrete aggregate. But this is not a resilient material. If you look into recycled concrete aggregate, it is a porous, it consists of the past aggregates or so-called the matrix in the aggregates. So that may not be conducive to use in a normal concrete. However, by utilizing these supplementary cementitious material, namely rice as cash, palm oil fuel ash, clinker powder, this can be durable. This can make this a durable. That's what we assess the durability, also using the microstructure characteristics. So what we did was we used a conventional oil, ordinary Portland cement, and use a normal aggregate. At the same time, we use the ordinary Portland cement, we use a recycle aggregate. It's two different aggregates. And these are the three different non-traditional supplementary cementitious materials used by my student. So what he did was he utilized 10% of rice as cash, 20% of rice as cash, and 30%. Similar thing he applied for the palm oil fuel ash and palm oil clinker powder. Then we utilized this coarse aggregate. So what we did was, based on the investigation, so we investigate the sustainability performance, durability performance, and engineering properties. So what you notice here is this workability was okay, considered the 30%. When we add 30% of palm oil clinker powder or palm oil fuel ash, the workability getting reduced, because the reason was this. You have seen it here, that this material is porous. When you see this, when it's a porous structure, they absorb the water, thereby the workability got reduced. That's a normal, that's expected because of the porous. So I have quoted here, rice as cash is a porous material, and this ordinary Portland cement is not that compared to this rice. So POCP or POFA, they have a porous structure, thereby they absorb the moisture, thereby the workability getting reduced. However, the relative compressive strength, we can see the RHA has improved the compressive strength of concrete rice as cash because of the silica. When we mix cement with the water, produces calcium silicate hydrate and calcium hydroxide compounds, whereas the calcium silicate hydrate is a strength producing compound. The calcium hydroxide is just standing there without contributing towards the strength. But when we add rice as cash, which has 90 to 80 to 90% of silicon dioxide, that silicon dioxide can react with the calcium hydroxide, which is a passenger, does nothing towards the strength contribution. Thereby, this RHA with their silica content or silicon dioxide content react with the calcium hydroxide, that produces more calcium silicate hydrate. Thereby, you can get the more strength in the concrete. That's what we have done. So this one also, compared to the rice as cash, palm oil fuel ash and palm oil clinker powder has a strength relatively after 28 days. Of course, it's understandable because these pozzolanic materials, they don't react immediately. They react after the 56 days, or 28 days. So you can see initially they don't produce the highest strength, but at the later stage, after 28 days, you can see the strength by the palm oil fuel ash or palm oil clinker powder is quite close to that. We also investigated, my student also investigated the compressive strength, flexural strength, splitting tensile, all these mechanical properties. And also, because of the time, I have not put all those values. However, for this durability aspect, acid resistance, we can see without any supplementary cementitious material, these two, normal aggregate concrete, this is a recycled aggregate concrete. We expected recycled aggregate concrete to have more deterioration compared to the normal aggregate concrete. However, when we add rice as cash of 10%, 20%, 30%, similarly, palm oil fuel ash, 10%, 20%, 30%, same with the palm oil clinker powder, you can see the reduction in the deterioration of the surface. So the results showing that recycled aggregate, this or recycled aggregate, this one, recycled aggregate based concrete containing rice as cash, palm oil fuel ash, and clinker powder have an improvement in the deteriorated layer. You see that this is more layer got deteriorated, whereas when we add that rice as cash 20% or rice as cash 30%, it got increased. It means the layer got, the durability got increased, whereas the layer got decreased. So that shows the durability is increased or durability is good. The deteriorated layer has lower depth here. So, okay, it was about 2 to 4 times than the recycled aggregate concrete, depending on the replacement level. So this is very important because, as I said, this calcium hydroxide has been consumed due to the supplementary cementitious material, that is the rice as cash or palm oil fuel ash or palm oil clinker powder. They do react with the calcium hydroxide to produce more calcium silicate hydrate. So you see the deterioration of the surface. Normal aggregate concrete, recycled aggregate concrete, you can see the damage, and you can see the recycled aggregate concrete with the rice as cash 30% compared to this. This is much better compared to the other acid resistance we can see, and also the compactness of the structure we can see. Rice as cash with the 30% of this one recycled aggregate cured in acid, but compared to this deterioration, we can see they are still intact. This rice as cash or palm oil fuel ash. This. So the cement matrix of the concrete blended with supplementary cementitious material has a uniform and more close microstructure here compared to this the recycled aggregate concrete. Because when this texture, you know, they are exposed to the acid or something, they have more porosity inside. But whereas these materials, when they ground, they react with the calcium hydroxide, they produce more calcium silicate hydrate gels, thereby the structure of the concrete is compact compared to this. And sustainability performance we got for 20% of replacement ratio as the highest efficiency of the sustainability performance. If you see this is 20% rice as cash compared to this 28-day or 90-day efficiency compared to the normal concrete. You see normal concrete, these are they perform better than this concrete, you know, this recycled aggregate concrete here. And this efficiency was measured in terms of strength per kg of CO2 emission per cubic meter. So you can see this. Okay. And a summary of this is to check the reduction in the water absorption was 29% lower. The chloride ion penetration was 76% lower because we also calculated the RCPT. So the chloride ion penetration was 76% lower. CO2 emissions was 29% less because we are utilizing non-cementitious, that means non-cement, means supplementary cementitious material instead of ordinary Portland cement. Thereby, you see that the CO2 emission is getting reduced. Also, the acid and sulfate resistance, the deterioration is lower, thereby the durability is good, and this is good for our concrete. Also, on the positive side, electrical resistivity, this is to measure the corrosion. If supposing there is a steel inside, we can measure the electrical resistivity. That is directly or indirectly gives you corrosion resistance. Thereby, it is improving 17%. We also tested up to residual with the temperature of 400 degrees Celsius. The residual strength was 17% higher. The ultrasonic velocity, this one is also indicating the uniformity of the concrete is 5% higher. The hardened properties, generally, we got 20% improvement. So this is generally what we have achieved from the this usage of the supplementary cementitious materials. Some are traditional, some are non-traditional, but we use non-traditional here. What are the non-traditional? We use rice as ash, we use palm oil fuel ash, and we use palm oil clinker powder. Up to 30% easy, it's possible, but we recommend up to 20% because of the durability aspect. 30% not good, but 20% is good for durability aspect. Okay, these are the 20 and 30 it's range, but 20% we recommend because of both considering strength and durability performance. But only for durability 30%. But if it's a strength and durability performance, we recommend 20% of these materials to be replaced. So these are some of the benefits that we mentioned. And I would like to also take you to the house that we built for for the school students, STEM students or others. It's called low cost model house. It's a resilient. I call it resilient because it can withstand, and it is a very good, it's a sustainable house. Why this is important for today, developing low cost or sustainable houses? Because we do not have a virgin construction materials or natural resources. We are continuously destroying our ecological balance. Thereby we dredge. Even you saw in the video, you saw there are tons of materials taken from the ground. Even fighting is going on for the sand, different parts of the world, not only in India, but different parts of the world, because sand is getting depleted. And dredging in the sea is a very, very dangerous, because when you dredge the sand beneath the ocean or beneath the seafloor, it is going to cause a tremendous catastrophe to the ecological balance. It has to be avoided at any cost. So 8 to 10% of the CO2 emission from the concrete industry worldwide, rising cost of the building materials. You all know, civil engineers, the economy is getting weaker, building materials cost is getting higher, and also the millions of houses to be built to meet the rising population. See, there are many youngsters today, they need houses to build. So it's quite important, the civil engineers' role in construction industry. Or also the government, many governments have introduced green building index regulation, GBI regulations, or LEED certification. Thereby we have to use non-traditional construction material or waste material as a resource in our construction. So in Malaysia, we have quite a lot of industrial byproduct. So we can see here, and we have used those materials as a what you call sustainable or resilient structure materials in our steel slag aggregate, palm oil clinker aggregates, and this oil palm shell we also used for the pavements. And the manufactured sand, instead of the conventional sand, we use the manufactured sand for raft footing and the load bearing brakes and pavement blocks. These are the things. And these are the powders we utilize. Palm oil clinker powder we use, palm oil fuel ash we use, the fly ash we used, and GGPS we have utilized in our construction here in this house. So we have gone to a factory called CKOI IBS, Malaysian Century in Berard. It's called Public Limited Company. They stopped their production, then they used our materials in the silos, and we were using a system from that company that called IBS, Industrialized Building System. That was consisting of raft footing, reinforced U-brick beam and column block, and brick wall and metal deck roofing. This is what we utilize. So you see that this whole place is with the foundation raft footing, because this is the car park area. You see that this is a road going towards this is a faculty road and departments. So we have to build a house here without digging the foundation. So what we did was we put some disturbance coming.
Johnson.
Can you inform the
join பண்றதுக்கா சரி உங்க மெயில் கண்டு இல்ல கன்க்ளூஷன் வந்துட்டு அந்த லோ காஸ்ட் மாடல் இருக்குல்ல அதுக்கு வந்துட்டாரு. ஏன் நிக்கிறாரு?
Are you with me?
சார்
Yes, sir. Yes, sir.
Can you mute them? Because some of them are causing disturbance.
Yes, sir.
Muted, sir. Muted.
Okay. Somebody has raised a hand. Sorry, just now I see Krishna Kumar. Is there anything? Krishna Kumar, Mr. Krishna Kumar or Dr. Krishna Kumar? I don't know. He raised the hand. Sorry, I don't see the hands now because I'm presenting. So anyone has a question, probably I can continue later after finishing. Okay. This is the house we built it for the STEM students, the school students. That means you see here this foundation using the raft footing or mat footing. This completely we use a steel slag aggregates, cement replacement. We use the manufactured sand instead of river or mining sand in Malaysia. And these bricks or blocks we built, we fabricated using our non-conventional material. Of course, we use cement, but to a certain extent. So this is the construction of the house with the 3 bedrooms, and this is a low cost house, so we cannot go for more than 900 square feet. So it's a low cost house. We built this with the 2 bedroom and a toilet here attached, and this is how we built the house. And this metal deck, because a low cost house, we can't go for reinforced concrete roof, so we used a metal deck and we completed the house. And this is the house today. Whenever I get students from France or China, India, or from other countries, I put them here, or school students, they come here. Okay, this is the green low cost house. Okay, we built there. So this one, no time, so I'm not showing the video. Next one, I'm moving towards earthquake resilient structure, because we also built, we also fabricated a slab using a blast resistant concrete. We call resilient. It can be used for earthquake or blast. So both places, this kind of concrete is quite useful. Today, we see that because of the blast, damage to the buildings, huge fire or complete destruction, even earthquake. We can see this is recently in Turkey, and so much of damage to the building, completely destroyed. So this kind of places, we need some structures, and that should be resilient. Case it should withstand. Resilient means it should withstand to certain external forces. So one of the things that we used was palm oil aggregate. It's a biodegradable, but it can withstand the earthquake or blast load. We have tested it. So you look at this palm tree. This is a traditional palm tree that is grown in these tropical countries. Each of these fruits, it means you can see this is a fruit. This fruit is almost 20 to 30 kg. It can weigh. And they have 1,000 of fruitlets, 1,000 to 3,000 fruitlets. And these fruitlets, they are utilizing this one to fuse the palm oil. And the waste that they get is this, that after extracting the kernels, means this is the palm oil they take from this one. I think this picture will give you some idea. If you look at this, the palm oil is taken from this yellow skin or the fruit, and they need to take the kernel is here. This is the kernel, and the result is they have to break this shell. This is called oil palm shell or palm kernel shell. So break this, then take this kernel. They take another oil from here, one oil, the cooking oil from here, or crude palm oil. Then they purify. That oil is coming from the yellow skin or the fruit. This kernel, they are also taking some oil for cosmetics. They use this kernel to take another oil. But this waste is dumped it, and we utilize these shells all over the palm oil mills. We can find this. So we brought them and we tested this for different properties. And you can see we replaced the conventional crushed granite. We replaced with the oil palm shell. And the properties that has more interesting feature is this aggregate impact value. Of course, the water absorption was quite high, but nevertheless, the feature or the important characteristic that we utilized was aggregate impact value. When you compare the crushed granite and the oil palm shell or palm kernel shell, it is 1/4 of this. Therefore, we can have more impact without crushing the aggregate. So what we did was we used the normal concrete. We also developed oil palm shell concrete, and we utilized the more cement. Normally in a lightweight concrete, we need to use more cement, that's expected, and we produced concrete of grade 30, around 30. This is normal weight concrete, density of 2300, whereas the density of our lightweight concrete is 1800, almost 22% reduction on normal weight concrete. Nevertheless, the strength was almost 33 here, 36, it's almost very close. But if you look into the modulus of elasticity, this is 26 gigapascal or kilonewton per mm square. This is only 12 gigapascal. When you have a lower modulus of elasticity, that means it will undergo more deformation. Whereas this one, if you look into this, this is the traditional the graph for compressive strength versus days, which I have shown you. This consists of a convex and the concave. This is the concave surface, the convex surface, and the broken surface. Different surfaces have a different characteristics. For instance, the bond between this convex surface and the cementing matrix will not be that good. Therefore, we have to use silica fume, which is 100 per times finer than the cement. They can stick to the CC that these pores, tiny pores on the surface, have to be absorbed by the cement particles, which is not possible. Cement particle size average of 40 microns or 60 microns cannot filter or penetrate these micropores. So what do? We have to use silica fume. When we use a silica fume, these 7-micron size of the pores are impregnated with the silica fume particles. Thereby, the bond between this surface and this convex surface and the surrounding matrix. When you have a bond, then the transfer of the force between the matrix and the aggregate will be good, and thereby it can lead to ductility property. So what we did was we investigated the structural behavior of the beam, lightweight concrete beam and normal weight concrete beam. So we fabricated a beam of 2.1 meter size, 2.5, but we have used 2.6, but we used the 2.1 meter span for our loading with the size of 150 by 250 mm cross sections. This is the beam we fabricated with all the strain gauges. We tested it with the instrument test under the instrument testing machine. LVDT was fixed and the DMAC gauges were used to measure the neutral axis and so on. You look at the picture. This picture shows that normal weight concrete, this is a normal weight concrete, the cracking patterns are straight and there are lower number of cracks. That means this crack will widen up when we apply load. This will be widen up and the failure is brittle failure. Compare this with an oil palm shell lightweight concrete beam. See, the cracks are double compared to the other one and the cracks are zigzag. These zigzag patterns show aggregate interlock and also the bond between the aggregate and the matrix. Thereby, you see multiple secondary cracks, and also these cracks are not widened up. Thereby, it shows the bond is quite good. So this one, no time to explain all. So what we did was even the strains, micro strain, if you look at the strains in the lightweight concrete, almost 10,000 micro strains compared to 3,000. Normally we expect 3,000 micro strain, the steel will yield. But this concrete did not yield. After yielding, it did not break, but it will continue almost 8,000 micro strain or even 10,000 micro strain compared to the normal weight concrete beam. Even the concrete strain was higher in here, you can see. So that led to us, because the time I am rushing, that led to us to test on the blast resistance of this concrete. So what we did was we fabricated a slab and we have a collaboration with the universities. This is the instrumentation. We fixed the accelerometer, LVDT, pressure transducers. These are the instrumentation when we test for blast. Blast means an explosion. You have to have an explosion charge. This is called stand-up distance 1.5 meters. That means you keep the slab at a distance of 1.5 meter between the explosive charge and the slab. This distance is called 1.5 meters. So all these instrumentations are sometimes get damaged because you use the explosive. When this explodes, there's a possibility the pressure transducer or accelerometer or LVDT getting damaged. So it has to be done very carefully. So our slabs were fabricated in Kuala Lumpur and with the help of University of Adelaide in Australia, University of Melbourne in Australia, and Beijing Institute of Technology in China. They have a base in China. This is me. I went to that place. It's a military site in China. They allowed us to go there, and we have transported the specimen from Kuala Lumpur to this place, Huludo, China. From the shipment from Kuala Lumpur Port Climb to a Tianjin port in China, from there by road around 500 kilometers. So this is the site. We did it in China. This is the explosive charge. You can see this Professor Wang is experienced professor in handling the explosive. He has been licensed to handle the explosives. So he was the one doing all the explosive charge placement and ignition. So this is what we did: 1.5 meter standoff distance, and this is the high-speed camera was placed here, and we have taken the test on this. So you see that after the blast consists of fire, blast consists of impact, blast consists of pressure. So pressure. These things happen. Our shell concrete, lightweight concrete, withstood all these. See, this is after impact, after blast, after the pressure. You see that this normal weight concrete shattered and hundreds of shrapnels. Then that's why people get killed. So I just show you a video because no time. I'm going to show another slide soon. So please.
Oil palm shells, once considered as a waste materials, is available plentiful in Malaysia and other Southeast Asian countries.
Our research enabled us to identify the ductility characteristics of OPS with collaboration of researchers from various universities and public bodies to explore the blast-resistant characteristics of oil palm shell concrete.
The attempt was a breakthrough as for the first time, oil palm shell, an agricultural waste, was used to replace conventional aggregate in the development of lightweight concrete, christened as oil palm shell concrete.
OPSC was designed and fabricated in the University Malaya laboratory, and then the specimens were shipped to Hiludao, China for testing. Blast tests were conducted on the specimens. After the blast test, the OPSC specimens showed ductility and impact-resistant characteristics such a way that not even a single shrapnel was found after the test on OPSC specimens. However, the normal concrete slabs couldn't withstand the blast test, neither the impact nor the pressure, completely shattered and damaged. There were a large number of shrapnel found from the shattered normal concrete slab. Thus, the research on OPSC slabs proved that OPSC could resist blast loads up to 10 kilograms TNT, despite multiple cracks and some deformation. The OPSC panels were able to resist the blast loads, and thus it paved way for further research and commercial interest for future application for blast-resistant application.
So this is about our shell concrete. So I'm not having time to go through why and so on. And I mentioned some points before. So that this is a ductile material. Also, we built a modern structure one building for bus drivers. This is we call cement-free or geopolymer concrete. This is also interesting. I don't have time, but I will show within 5 minutes. Then I move to the another slide. I don't know how many of you are listening, but those who are listening to me, maybe you can get you take 2-3 points away from this lecture for your research or your teaching. Resilient modern structure, that's the topic, modern material for resilient structure. So we built a geopolymer concrete house for bus drivers. We were challenged to build a house, but we didn't have a finance. So we knocked the doors of few companies, and one French company in France, Paris, they helped us to finance the project. So we built a house. This building was built using geopolymer concrete, and these are some of the interesting data. What we did was most of our densities were less than 2,000, means it's lightweight, lightweight concrete. And the strength of this material, even 28 days, we managed to get 45 megapascal. This is purely cement free. We did not use any cement at all. We don't show all the materials here, but we used cement free materials, 100% eliminated cement. So then when we built beam for the beam and column, we had a strength of 47 megapascal, and the lightweight concrete below 2,000 kilogram per meter cube, it's called lightweight concrete. So and we use fly ash, palm oil fuel ash, GGPS, and sodium hydroxide, sodium silicate, manufactured sand, and palm oil clinker as an aggregate. You see, no conventional material, no mining sand, no river sand, no ordinary Portland cement, and so on. So this is what for the hollow blocks. We also developed hollow blocks. You can see that me showing here some of these are hollow blocks. These hollow blocks had a strength of 12 megapascal. That's quite extraordinary, this hollow blocks. A size of 390, 140, 175 height. This is the hollow block dimensions. And we were challenged to build a house for the bus drivers. There are 30 over buses parked here. These bus drivers usually sit in the containers. This container is not suitable for them. So we were challenged. We removed the container from that place, and we excavated, we tested the soil investigation. It proved to be a very bad place because they were dumping all the wooden abandoned waste, others in this place. So it's like a wasteland without any soil bearing capacity. SBC, say, bearing capacity is almost nil. There's just like a pile of wood at the bottom or the trees. So we have to put up some structure, strong foundation, resilient foundation, and we build the house. All the panels, wall panels, or the hollow block, this is by student design. This is conventional design, but cement-free material. Everything is geopolymer concrete. So we build the house using the columns, beams. Even this is the in situ concrete. We did not cure it in the curing chamber. Those days we used curing chamber, but we did not use a curing chamber. Rather, we used columns and the beams, everything constructed. And this is the house we handed over to the bus drivers now. They are happily sitting there. So this is during the inauguration. This is me, and this is the company that provides the finance. This is the director, managing director of the company. So this is handing over the rooms, our rooms to our own research center, because we are using one or two rooms there, and this is the bus driver's manager to receiving them. So this is what we talk about until now. Maybe I have 20 minutes left. According to Sir Isaac Newton, my powers are ordinary. Only my application brings me success. So we need to apply our basic materials to success. So I stop here. If you have any questions, I can answer. I'm going to another slide, few slides, to show our teaching, how we can enhance our teaching. So if you have any questions, please let me know.
I go to the next slide.
If no questions, then I can go to the next one. It's called, let me open the slides.
Sir, you told you're using palm cells and all, sir. Will there be any degradation? It is all organic products.
Yeah, 100% biodegradable. I can assure you, these materials don't stand for a long period if it's not protected. See, what is our suggestion? When you use this, water absorption for the conventional crushed granite is 2% or 1%. But this one has a 20% water absorption. It is not at all durable, because when they absorb the water can transfer to the steel bar, and then corrosion can happen. So what we should do is, we ensure, if this is going to be used for special structures, supposing you are having explosions in the case of armed bases or military bases, they have hundreds of tons of this explosive charges stored there, or gas cylinders in the case of the gas producing company, or wherever they use the gas cylinders, we need the protection. What we do, I'm suggesting this to some of the military or other personnel. You fabricate the slabs, 2 meter thick or 1 meter thick of slab, or half a meter thick slab, or 200 mm thick, so whatever is it, using this oil palm shell, but make sure it is watertight, waterproof. So once it's a waterproof, you can use it any place, because we have advanced technology to ensure the waterproof is done. So that this, some researchers have done, reduce the water absorption capacity within the aggregates. But I would suggest, as long as it's ensured waterproof, water tightness of the whole slab, we can stand for many, many, many years. So after 20 or 30 years, if there is any deterioration, replace the slabs. Because what is our ambition or aim, what is our objective, is to ensure when there is an explosion, when there is an accident, or when there is like an earthquake, these kind of structures can be utilized. It can resist earthquake, it can resist the blast and impact. That is our idea. Is that okay? Am I answering your question, sir?
You are correct, sir. Is this the general procedure for all organic products?
It depends. You have to go case by case, I would say, because this has got certain pores inside. We have investigated. The pores are tiny pores, 18 micrometer, 25 micrometers. So these pores can only be filled with the silica fume. You can't use normal cement. So in addition to normal cement, you need to use the 100 times finer material, or some finer than cement, so that the bond is quite good. Once the bond is established, the strength is also good, then the ductility characters improves. So depending on the material, sir, I would advise go case by case. Thank you.
Thank you, sir. Thank you, sir.
Okay, I am sharing now one more slide. I don't know, you can see the slide. This is on teaching. Most of you are in teaching. So, we need to develop our skills. I don't know how many minutes I have time. Hello?
Hello.
How many minutes, Mr. Dr. Pradeep or the organizer, how many minutes I can have?
So 15 minutes more, sir.
Okay, I have 15 minutes. Okay, let me share also one short video. So I am not going to, it will take a long time, but we need to have skill ourselves, develop our skills to be effective teachers and researchers. So there are a lot of things to share, but I don't have time. I have been to many universities to explain this directly to the lecturers and students. So because it's civil engineer, Institution of Engineers, Civil Engineers, UK. This one I never knew when I went to Middle East to work on those days. Today in University of Malaya, I have to be a chartered civil engineer to teach. You might be surprised. In India, it's not the case, but maybe in 10 years' time, they may ask you to be a chartered civil engineer. Or I'm also a PE. PE is called professional engineer. They call IR. So in my front of my name, you might have seen it. This is IR. IR means engineer. That means professional engineer. I have to be professional engineer to teach in my university. So that's a rule. I have to be a member of Institution of Engineers Malaysia or certain bodies. So this is a mandatory nowadays. So you have to continue to develop your skills. I'm not going to teach explain on this, but you need to professionally, you need to develop. So this I'm stopping here because I have 10 minutes. Maybe a short info on the teaching. Maybe this video is 7 minutes video will help you to understand the significance of our teaching. How important our teaching. Maybe this video.
Arun Kumar caption போட்டுருட்டுங்களா? Arun Kumar, yes. Dot வச்சிருக்கீங்க.
As she stood in front of her 5th grade class on the first day of school, she told the children an untruth. Like most teachers, she looked at her students and said that she loved them all the same. However, that was impossible because there in the front row, slumped in his seat, was a little boy named Teddy Stallion. Miss Thompson had watched Teddy the year before and noticed that he didn't play well with other children, that his clothes were messy, and that he constantly needed a bath. And Teddy could be unpleasant. Got to the point where Miss Thompson would actually take delight in marking his paper with a broad red pen, making bold X's, and then putting a big F at the top of his papers. At the school where Miss Thompson taught, she was required to review each child's past records, and she put Teddy's off until the last. However, when she reviewed his file, she was in for a surprise. Teddy's first grade teacher wrote, "Teddy is a bright child with a ready laugh. He does his work neatly and has good manners. He is such a joy to be around." His second grade teacher wrote, "Teddy is an excellent student, well liked by his classmates, but he is troubled because his mother has a terminal illness, and life at home must be a struggle." His third grade teacher wrote, "His mother's death has been hard on him. He tries to do his best, but his father doesn't show much interest, and his home life will soon affect him if some steps aren't taken." Teddy's fourth grade teacher wrote, "Teddy is withdrawn and doesn't show much interest in school. He doesn't have many friends, and he sometimes sleeps in class." By now, Miss Thompson realized the problem, and she was ashamed of herself. She felt even worse when her students brought her Christmas presents wrapped in beautiful ribbons and bright paper, except for Teddy's. His present was clumsily wrapped in heavy brown paper that he got from a grocery bag. Miss Thompson took pains to open it in the middle of the other presents. Some of the students started to laugh when she found a rhinestone bracelet with some of the stones missing in a bottle that was 1/4 full of perfume. But she stifled the children's laughter and she exclaimed how pretty the bracelet was, putting it on and dabbing some of the perfume on her wrist. Teddy Stallard stayed after school that day, just long enough to say, "Miss Thompson, today you smell just like my mom used to." After the children left, she cried for at least an hour. On that very day, she quit teaching reading, writing, and arithmetic. Instead, she began to teach children. Miss Thompson paid particular attention to Teddy. As she worked with him, his mind began to come alive. The more she encouraged him, the faster he responded. By the end of the year, Teddy had become one of the smartest children in class. And despite her lie that she would love all the children the same, Teddy became one of her teacher's pets. A year later, she found a note in her drawer from Teddy, telling her that she was the best teacher he ever had in his whole life. 6 years went by before she got another note from Teddy. He then wrote that he had finished high school 3rd in his class, and she was still the best teacher he ever had in his whole life. 4 years after that, she got another letter saying that while things had been tough at times, he'd stayed in school. He'd stuck with it and would soon graduate from college with the highest of honors. Again, he assured Miss Thompson that she was still the best and favorite teacher he'd ever had. Then 4 more years passed, and yet another letter came. After he got his bachelor's degree, he had decided to go a little further. She was still the best and favorite teacher he'd ever had. But now his name was a little longer. The letter was signed Peter F. Stallard, M.D. The story does not end here. There was yet another letter that spring. Teddy said he'd met this girl and was going to be married. He explained that his father had died a couple of years ago, and he was wondering if Miss Thompson might agree to sit at the wedding in the place that was usually reserved for the mother of the groom. Of course, Miss Thompson did. And guess what? She wore that bracelet, the one with several rhinestones missing. Moreover, she made sure she was wearing the perfume that Teddy remembered his mother wearing on their last Christmas together. They hugged each other, and Dr. Stallard whispered in Miss Thompson's ear, "Thank you for believing in me. Thank you so much for making me feel important and showing me that I could make a difference." Miss Thompson, with tears in her eyes, whispered back. She said, "Teddy, you have it all wrong. You were the one who taught me I could make a difference. I didn't know how to teach until I met you." You can never tell what type of impact you may have on another's life by your actions or lack of action.
I think this, I don't know how many of you watched this video. If you had watched it, probably you will see the impact. The bottom line of the story is that every one of us meet the students of different what do you call the backgrounds. Yeah? So we don't just look at the grade. We don't just look at the students' attitudes just because of one day action or one day moment, but rather we need to think of our life can impact others. Because if you look at their backgrounds, probably, in the story here, he lost his mother at the very young age, so he had to go through a pain and suffering. So similarly, we also have students in our class. Maybe they have some attitude issues, they may have some emotional issues, financial issues, and many. I remember met many students. But how do we make a difference in teaching? So we need to give attention to those, not to those who are well or those who are smart students, but also those who are poor, those who are weak, and those who need our attention. So in our class, we should remember to reach out to those and make an impact. I know the time is short. I'm not going to touch on the article writing because there are quite a number of things I need to go through, but it will take a longer time. And just one slide probably to say this right of the journals, because it's quite a lot of things. Maybe one thing in your article, see, the important aspect, if you are writing an article, I have 2 minutes to just close. So what are we going to put in our articles? You see, there should be a novelty. For example, I am an editor, I am an associate editor in 2 or 3 journals. When I receive the journals, I look in for some kind of invention, some kind of novelty. So what is the novelty you need to mention? You see, so I'm going to show introduction. This very important is you have to show the introduction. What is the novelty? Very important is novelty. What is the new compared to the past? So these are some of the points. Because I have so many things, I have to go one by one, but you need to understand the research gap. So what is the gap that you fill in? What is the main finding? What is the current area, and what are the things that lack, that need the research, and highlight the previous research. This is very important. I see many articles, we reject it because those students or the researchers, they don't address the novelty, the research gap, and what is the significance of the research. Why should they do the research? And one of the things I see from some of the countries, they don't have in-depth knowledge. They don't write in-depth discussion. They just discuss the results or write the results. They don't discuss it. That means the lack of in-depth discussion, in-depth scientific description, in-depth analysis compared to the past and present, or the similar research. That's very important. So the very important is to write an article. So very it requires skills. Probably I have to give 2 hours lecture on that. If you are interested, you can invite, and I'm going to BITS Belani next month, so I may have some time to share with those. So I have visited many universities, but only thing worrying is China is producing the most number of articles in the world. America is going behind. Europe is going behind, but China is storming the world with hundreds and thousands and millions of publications. We are not going near anywhere. So we have to put a lot of efforts to address this issue. With that, I would say thank you very much, because I don't have a time. I know another the next lecture is also next expert lecture is waiting, and I would like to thank you. I also thank Dr. Pradeep from I think Erode Institute of Technology. He invited me, and also the organizers at this conference or this faculty development program. Thank you very much for inviting. I can see around 70 people there attending. Really appreciate your time and your effort. With that, thank you. Have a pleasant evening. Bye-bye.
Chad narrated about his university, collaboration with other universities, and about his ranks. He discussed cement consumption in the world, different properties of materials, sustainability performance, construction of low cost cement, low cost model houses, challenges by construction materials, depletion of virgin construction materials and natural resources, CO2 emission, and rising cost of building materials and industrial byproducts. He connects civil with instrumentation and he has given guidelines regarding article writing. Thank you for your wonderful session, sir.
Many thanks, MC. I think you have observed the points. Very much appreciated. Bye-bye.
Thank you, sir. Followed by Dr. A. Sudhakar sir for 12th session of 6th day faculty development program on disaster management in Odissa. Already he handled the session 7th on day 4th. We welcome you for the session, sir.
Very, very old. I think that should be in place. I would also recommend to have a ham club, ham radio club in your institutes and train your students on how to become members of a ham club and use the ham radio facility, because that is going to be very, very handy in terms of emergency. That is almost 100% sure way of getting communication with the rest of the world. And this district plan also has an elaborate plan on creating information, literature, videos, demonstrative videos, all those things, animations and all, on how to react during a disaster. And this plan will be reviewed annually, as I told earlier. So these are the powers of the district authority. They give directions, they control and restrict vehicular traffic in terms of emergency. They will supersede the police and they will define the traffic control route. They will control and restrict the movement of any person inside that vulnerable area. I had this experience recently. I went to Tiruvannamalai for a pilgrimage. I wanted to go and see the landslide affected area. I was not allowed. Of course, then I had to explain my background, where I am coming from. I'm interested academically to know the failure pattern and all. Then I managed to get permission and then go. But yeah, it is the district authority who will allow or disallow anybody to go to the affected areas. They are in charge of removing the debris and the to be removed articles from the affected site. They make arrangements for the disposal of unclaimed dead bodies. This is also very important because they are empowered to do that. They recommend plans for the other department. They procure the basic material as discussed earlier. They are empowered to order for the demolition of a partially collapsed structure or a potentially dangerous structure which is still standing there post the event of the disaster. And they ensure control on the NGOs, the non-governmental organizations. They don't actually integrate with each other. If there are 3-4 NGOs working, they will have their own style of working, and maybe they'll be at loggerheads. And we had incidents where they had fought with each other, and ultimately no relief reached the affected victims. So these are some of the facets of the local authority in interfering with the disaster management. So for the financial aspect, central government has already allotted the NDRF, National Disaster Response Fund. You will also have the Chief Minister's Relief Fund. Odisha has got a state disaster response fund also. There is also something which was built, but it is not implemented. It is called the National Disaster Mitigation Fund, which is more preventive. But for some reason, the government has not implemented it yet. Probably very soon they will implement, because this will help in capacity building at a national level. State governments have these disaster mitigation fund, state disaster response fund, district disaster mitigation fund. All these are the financial aspects at the state level. But what happens is every ministry or the department will make provisions in its annual budget in terms of doing activities for disaster management. For example, it's the telecom department. Telecom department will conduct a fire safety drill. It will conduct a mock drill in their own offices. For this, fund is required, right? So this will be incorporated in their budget, and it will be approved by the finance ministry as per the advice from the State Disaster Management Authority. So these are this is a unique thing. This is the only state which has got a separate code. Of course, it says you have to get the permission of the authority to implement it, but it has got provisions to punish anybody, an NGO or an individual or an organization which will obstruct or refuse to comply with the direction of the government. If somebody says you all evacuate and get into that school, and somebody says no, I cannot leave my house, then the authority has got the power to punish him. And there is a punishment for false claim. If you are not really affected but you claim a relief, then there is a punishment recommended for that. Punishment for misappropriation of money and scams. Punishment if some disaster warning is falsely given. Even the head of the departments or the chief secretaries are liable to punishment. And if anybody obstructs an officer to perform his duty, of course, he'll be also punished. So this is one unique thing about the state, because it has at least got a mechanism to stop the autocrativeness or the red tapeism. Because if you do something wrong, you have provisions to be punished. So, but this is a kind of a, what do you call it, hindrance. The court of law cannot take a suo moto decision to punish somebody. It has to get an approval from the national authority or the state authority. Or any other authorized person. And you have to give them a notice of 30 days or a show cause notice, giving them 30 days time period to respond to the allegation or the accusation they are facing. So these are a list of some miscellaneous powers given to the state authorities. I was talking about this, the National Disaster Management Institution mechanism. See how well integrated all these committees are. So none of them are not separately circuited. So overall, it is like you enter anywhere, you can reach anywhere. This is how it has been designed. Of course, it is now in a kind of a testing period. I hope the feedbacks will be well received and the system is made more robust. So these are the list of ministries. You should know who to contact when. If it is a biological kind of a disaster, you should call the nodal agency would be Ministry of Health and Family Welfare. Chemical and industrial accidents, Ministry of Environment, Forest and Climate Change. For flight accidents, the civil aviation accidents, it is Ministry of Civil Aviation. For cyclone and tornado, it is Ministry of Earth Sciences. Tsunami, same. Drought, anything related to agriculture, the Agricultural Ministry will become the nodal agency. Earthquake, Minister of Earth Sciences or the Geological Department, as we call them popularly. Flood, it will be the PWD or Ministry of Forest. This is the list. I'm going to share this list to you. So these will be the nodal agency to act in case of this the disaster is of that particular category. Like the national level, at state level also you can see a well integrated system, and this is being improved day in and day out. So I will skip these slides, except for I am bringing it to your attention that Panchayati Raj and even corporates can be a part of the stakeholder committee, and they can pitch in their services and also inputs and also their demands. There is a special relief commissioner for the entire state of Odisha. I told you earlier, he is highly empowered. He is equal to the chief secretary of the chief minister of the state government. So he does all the control, and it is his efficiency which is going to be the result of the entire disaster mitigation plan. So I have listed down an elaborate role clarity or the SOP for each of the authorities, starting from the Special Relief Commissioner and next at the district level for the collector. So the salient features to sum up, I think the uniqueness of OSDMA, the Odisha State Disaster Management Authority, is to prepare for long term and not for short term. They have well grown in capacity building. Each district has got well trained officers and volunteers and NGOs who can act immediately upon a disaster. The whole community is aware. You go to any rural place, somebody knows what to do when there is a snake bite. Even very recently, I think I saw in the TV that somebody had a snake bite. He immediately caught the snake, put it in a plastic cover, and went to the hospital just for the doctors to know what kind of snake has bite him. So the community awareness has been well established, and they have constructed ready to occupy shelters in case of flood and cyclone. They have done a wonderful work, and this is how they have done it. And primarily, it is due to their focus on long-term preparedness. Now, let us look into a small case study. This is a very recent cyclone. So, 2009 cyclone, the super cyclone Bob 06, initiated the whole concept of disaster management in Odisha. Now, let's see what Cyclone Fani did. It happened in April, somewhere in April 2009. While that happened, I think it was in October, somewhere between October 25th and 31st was the first super cyclone. So, this is in April 2019. It actually affected almost the entire state. You can see the shades. So this is the shading according to the vulnerability index for cyclone. So this is, you can see the difference. The super cyclone of 1999 exactly hit the coast. It had the maximum wind speed when it hit the coast, and this is where it originated. I think you are able to see my cursor also moving. This was the path of the cyclone moving. It moved somewhere from somewhere near to the Indonesian islands on to the north of Andaman and Nicobar, and then it hit Orissa, and it also had an impact on the coastal Andhra Pradesh of that time. So this map shows the really intensely affected region of the state. But coming to Fani, it did not come from Indonesia. It was between Andaman and Nicobar Islands and the east coast of India. So, on somewhere around on 25th, 29th April, this started gaining into a cyclone, and it evolved into a super cyclone. And on 3rd May, it actually hit the coast. So this was the path for Fani, which means this. I put this because this was more intensive than the super cyclone, because it had to travel only small distance when compared to the previous one. Now let's look what happened in between 1999 and 2019. In 1999, Odisha was one of the poorest states, where more than half of the population was below poverty line. Disaster preparedness was very less. Due to the impact of super cyclone, the 12 districts were almost devastated. record says, the official record says 10,000 people, but actually 30,000 people were almost dead, and around 25 lakh animals were dead. You can see you can gauge the intensity. Now this data says 12,000, some data says 30,000. Let us not be too much bothered about the exact numbers, but at least we can know the range in which the effect has happened. But what happened was, upon receiving the early warnings from the Indian Meteorological Department, there was a very quick response from the government. It evacuated close to 1.55 million, around 15.5 lakh people, into 10,000, closely up to 9,000 shelters, which were pre-constructed and ready. Okay, so this is not a easy job unless they had a very careful plan, which was what you call tested, and or at least a dry run would have happened, and they were ensuring its efficiency. So the fatality rates was very low. Let's see what happened. On 1st May 2019, collectors of the coastal and adjoining districts were instructed to do the following: identify all vulnerable people and shift them to safe shelters, provide special care for the old, physically challenged women and orphans. I have told you it is there in their policy. They had excuse me, I'll just tell them I'm in an online meeting. So see, you would have read the things by now. So what happened is, this demonstrates how ready they were, how prepared they were, and nobody had a hesitation or a confusion on whom to approach and where to approach. Now you look at this figure. Now this is what reveals the whole story. It is the human casualty. Even though it was more intense, see, from 10,000 fatalities, they came to 64. In many districts, it was 0. Even the 64 should not have happened. I pity the victims who lost their lives. But coming from a number of 10,000 or 9,997, which is the least available number estimate on the fatality of the super cyclone in 1999. In 2019, they came to 64, which is a phenomenal testimony. It's a testimony of how a concentrated, sustained campaign or a plan of a government can work on the well-being of its citizens. Okay, these are some information on what was given, how much kilos of rice were given, all those things. But the moral of the story would be on how successfully they were able to manage the cyclone number 2, the super cyclone number 2. So they have very intelligently thought strategies. The recovery costs were well perceived and well audited before they were implemented. So I would not bore you much with information stuff. I have something on the way forward in the next few slides, and then I think then we can close. So this cyclone Fani was not actually seen as a great threat or a great effect for the government of Odisha. Rather, it was an opportunity to rebuild assets and livelihoods. The government took it that way. I was mentioning about the moral aspect of the disaster recovery plan. This is how the government itself took it. The government upgraded many public buildings. So It is a nicely thought recovery effort, not a reactive kind of an operation. It was more a responsible and well thought, prepared plan. Now coming to connecting this whole discussion to the FDP program. I think I was just listening to the previous speaker also, and he was also appealing how this information or this thought process or this uh, facet of citizenship. If you are a citizen of some country, then I think you should be prepared to help the country in terms of disaster. So this can be done more effectively and efficiently by youngsters. So therefore, it is very imperative that we will take it to the students down the line. And engineers can do more in terms of calamity, more than any other department. Of course, it is debatable whether the health department or the engineering department will do more. But nevertheless, we have a great potential of contributing towards the recovery of the nation after a disaster, for which we should not be acting like this. This is a newspaper cutting. I took it from Kerala. I try to put this in many of my presentations. Probably Shanmugam sir would have already seen this slide in any of my technical presentation. The rule of the land that time when this newspaper cutting was taken, I think it was at least 12, 14 years ago. The person sitting at the back need not wear a helmet. So this guy had made the small boy to wear the helmet, but this was not the spirit of the law. The point I am trying to make here is we tend to comply certain policy. For example, the Green Building Code, the LEEDs certification. All these policies we tend to only apply it theoretically, but not as per the spirit of the rule itself. So my concern would be to take it to the next level by actually organizing a kind of a well drafted document or a policy, and not to follow the policy in terms of its literal meaning, rather than go for the spirit of the policy itself. So somewhere if we start to improve, it need not be a full-fledged mobility or a full-fledged mechanism always. This is a jugaad what few people have done against the rain. I'm taking this only as an example. So don't take it very literally that you have to do these things. But these are the areas I'm talking about, baby steps. Okay. And we should also appreciate the fact that we tend to stumble when we do a familiar thing in an unfamiliar environment. So in Tamil, we have what you call it. It's not a proverb. It's not an idiom. It's an idiom saying that அவசரத்துல கைவிட்டா அண்டால கூட கை நுழையாது. I don't know how many of you are from outside Tamil Nadu, but it means like when you are panicking, you can't even put your hand into a large vessel, the anda. So the problem with disaster mitigation is that everybody panics. So this human aspect of attending to disaster mitigation has to be dealt with carefully. We as teachers, we should be able to conduct mock drills. We make the youngster be more prepared to accept the situation and start performing without panicking, even in an unfamiliar environment. So I have, and it is of course the attitude. You cannot be like what happened in Tirupati was an example. First people thought how greedy the people were. They stamped those 6 people, and they wanted to get their token or ticket or whatsoever. Then further investigation revealed that more people ran out because of panic that they would be killed, and therefore they did not mind the stampede which happened on other people. So it is not the attitude but the action which arises out of the attitude which matters most during a disaster. And this is a nice thing to follow. This graph shows 4 quadrants where the y-axis represents the following of rules, how meticulously you follow rules, and the x-axis on ethics and y-axis on rules. So in the top right quadrant, you have this. This is not a religious preach anyway. I'm only using these characters from our well-known epics. I'm not endorsing any religion or so here. See what this Rama depicts is he was very high in ethics and rules, dharmam and nyayam. We call it in Tamil. He was good in dharmam and he was good in rules. So, like he obeyed the rules of the war. When Ravana did not have a weapon to fight with him, he did not kill him. He asked him to come back next day. All these were virtues of this gentleman Rama. So he was epitome of, or he was a symbolization of somebody who was the epitome of rules and ethics. But his opposite was Ravana. He abducted the person's wife. The way in which he abducted also was very, very cunning. All those things were there. Now come to the other 2 characters. The top left is Duryodhana. This guy also was very high in rules. He did not flaunt any of the laws of fighting the battle. He fought it very honestly. But you see Krishna, who did lot of strategies, very, very smart and strategies in which he confused the opponents and made Arjuna win or the Pandavas win. But the moral of the story of this graph is whenever it comes between a conflict of rules and ethics, I think we should be holding ethics more than rules. And that is what I was trying to tell through that helmet example also. So in case you have to evacuate somebody, don't worry if it is a one-way or something. If it is a one-way, but it will take you to the hospital more quickly, then I think you should have your brains to give some proper signaling and get into a one-way and get the person saved. So this is a very practical dilemma which happen when there is a calamity. For example, when there is a when there is an accident and you people are panicking whether to help the victim or not. So don't worry about the rules. Be happy about the ethics which is being followed. So that is the moral of the story, and we have heard of this story. Whatever models you build could fail. So but that doesn't mean you will have to stop building models. You have to try again so that you will get a successful model one day. And don't try and be bogged down or be worked up by the fact that things are not changing. If you cannot change something, you have to endure it. So for example, you are trying to change the rules in your institution on the evacuation plan or something, but your management doesn't accept it. Out of that 8 ideas you have given, you are only approved of 2. At least start with 2. So that is what is what I am trying to tell you. And whenever you are trying to form a local level disaster mitigation policy, you can follow this. This is again not a religious preach, but you can see this Lord Vishnu having two animals with him. One is the snake and the other one is the Garuda or the eagle. So this represents 2 terms of vision or 2 types of goals, which is the short-term goal and long-term goal. You can see in this picture that the snake is being carried or being controlled by the Garuda, which means the short-term goals will always have to be in alignment with the long-term goals. It cannot be contradicting with the long-term goal. So a lot of models, especially in disaster mitigation, has failed because you do something very haphazardly for somebody to clap or appreciate or sing praises for you, but it doesn't align with the long-term policy of rehabilitation. For example, if you give money immediately, they are happy. But if you have not rehabilitated them for a sustained income, then they might get lost, or some victims have become antisocial elements also. So this is where I am trying to bring your attention that always the mitigation strategy should align with your long-term goal. I think we have 5 more minutes to interact. I think I know this was a little bit of a boring stuff. This is not engineering or technology, but still, this was a very important topic to be discussed today. And I thank the organizers for having given me this opportunity and having put across certain points. But again, there is still a lot more information available. I think the Odisha State Disaster Management Agency is ready to support institutions anywhere in India on trainings related to this topic. So if you want more, you can contact them and get 2 or 3 training programs for your institute as well. So over to the organizers.
Participants, do you have any queries? Can ask now. So let me conclude, sir.
Yes.
Odisha and disaster management. Odisha in 1999, 10,000 lives lost due to super cyclone. Because Odisha is a coastal area, he explained climate smart disaster risk management in Odisha, relief measures, administrative relief organization, power and functions of NMDA, connected disaster management of Odisha with Gujarat. He dealt different case studies regarding cyclones April 1999, pre-disaster management for super cyclones. Thank you for a wonderful session, sir.
Thank you, ma'am.
Thank you, sir. Participants, kindly fill the feedback form for the session.